Hi, so my name is Marcus Ryder, and this is my presentation for Everyday Physics CRN 30719. This is the spring semester, and so today I will be building a parallel circuit and a series circuit. So I'll show you how to do that. And so the supplies you'll need some light bulbs and a bunch of wire, and I want some wire cutters just in case. You definitely want wire cutters. I have it around just in case I need to cut more. And then you also need a battery, and for this I am using a 9-volt battery. And cool, let's get started. Okay, so first I'm going to build a parallel circuit. And actually, when I was trying to build this, I was let me angle my camera down and give you some commentary. Well, here, first of all, this was my my idea for holding things in place. I kind of made a grid of rubber bands on a sketchbook, so that kind of hold things in place a little bit. So that's cool. So I was actually not able to make a parallel circuit just with my previous physics knowledge and what I learned from the textbook. I guess I just maybe had kind of forgotten the important stuff about building one. So I actually needed to look up on a website. The website I found to use for this was nde-ed.org from NDT National Education Resource Center. That website was very helpful in helping me build a parallel circuit. And so first, okay, so here, let me show you what I'm doing. So right now I'm trying to wrap this wire around the negative terminal of the battery. And maybe it's a lot more trouble when you're doing it on video. Let's just wrap that. That'll work. Okay. So now slip that under there. Okay, so now that so let me show you what we're doing here. So we're gonna wrap some wires around these light bulbs eventually. Let's see, first so I already kind of bent this out a little bit of the shape that we want, and so we're gonna do that same thing here. That was that other one was from the previous time I built this. Let's see, so let's do this. Cool, and then circuit is gonna branch off here, just like that. So we got the wire going like that, and I'll give a little commentary as we go. Relating to circuits, I found on ScienceDaily.com, according to an article published on this website on September 9, 2009 from the University of Washington, written by Hannah Hickey, that some people, using only the power generated in trees, they were able to actually build a circuit, and they were able to run that circuit literally only using the power in the tree, which is pretty wild. So yeah, the people involved with that project were Babak Parviz, Carlton Himes, Brian Otis, Ryan Ricchiuti, and Eric Carlson. And this technology in the future, it could be used for sensors to indicate how the environment is and also indicate forest fires. Pretty cool. And let's see, so now we're just going to wrap each of our light bulbs. Do something like that. And let's wrap the other one too. Yeah, and in addition to this, according to the article, running a circuit off of that, people are actually able to tell the health of a tree by how much power it outputs. So that's pretty cool. Another use for that. Oh, my circuit's falling apart. I'm sorry, guys. Wrap that better. Okay, so there we go. Those are wrapped. Now what we want to do is so I already got this kind of bent out that shape that I want. And now we're just going to kind of think about how we want this to be. So let's do something like this, because so I got this wrapped around. So basically the wire has to go through both parts of the bulb. So it's going to go through this part, and it's also going to go through that part. So it's wrapped around this part, and now it's got to touch that on the bottom. So we're gonna build a circuit that will do that for each of these. Oh, what is going on? Pesky circuits. Yeah, so basically I got this branch here, and when the current gets to this area right here, it's going to branch off in both directions, and then it will it'll basically split up evenly and go through both of these light bulbs or resistors, and then it will join back up after that fork. So let me twist this together real fast. Alright, so I'm going to have to kind of hold these in place a little bit. The rubber band system could be utilized better here, but so now if I'm going to try to get this on camera. Alright, so now we just have to connect this to the positive terminal of the battery, and it should work as long as these rotten things would stand up and be touching the wire. Oh baby, we saw a light. This is very difficult to do. Uh-oh, we're lighting one of them. We're lighting one of them. Yes. Yes. Yes, no. Yeah, there we go. Alright. Now that was a struggle right there. So a parallel circuit is actually going to be brighter than a series circuit, which I'm going to build next. And actually, in a parallel circuit, the resistance is actually added up in a different way. So I'm going to stop that. You get the idea. So basically, the more resistors that are added, the lower the resistance in the whole circuit actually is, which is pretty interesting. You add the reciprocals of the resistances, and then take the reciprocal of that total to get the total resistance. So that's pretty interesting. And now we're going to build a series circuit. So let me take this apart a little bit. Hopefully we can kind of utilize some of these ties that we already got here. Cool. And so yeah, so now I'm going to build a series circuit, and to build this I'm going to be using my knowledge of circuits and also the textbook that we use for this class, The Physics of Everyday Phenomena, Conceptual Introduction to Physics, published in 2015 and written by W. Thomas Griffith and Juliet W. Brossing, and maybe the website mentioned earlier, nde-edu.org, helped too when I built that parallel circuit. So cool. Now we are. Oh, I should have left that one attached to the battery. That's all right. We'll do it faster this time. So yeah, just going to attach this to the negative terminal, like so. Cool, and let's lay that down. Now, I'll give a little more commentary as I build this circuit. So basically, we want this to run through both of these light bulbs. And cool, so we'll do that. We want the current to run through both of these light bulbs in a series instead of in parallel, where it was branched off and the current could split up and go to either one. This is just going to have the current go through both of them, and it doesn't have the option. So let's just wrap that. All right. So cool. So let's get this under my rubber band and utilize this system I got going on here. It's pretty cool, am I right? All right. So yeah, a little commentary for this one. So on physics.org, I found an article where physicists actually turned a crystal into an electric circuit. And it was called, the article was called "Physicists Turn a Crystal into an Electrical Circuit," and it was from Wahington State University, published on this website on July 27, 2017, and written by Eric Sorensen. And yeah, it was pretty cool. People were actually able to build a circuit on a crystal by etching a line in with a laser, and then connecting electrodes to both ends of that line. Pretty crazy. So yeah, now we got this here. So basically, we want, once again, we want the current to run through both parts of these. So we're running it through the bottom here, so let's connect it there, and then as long as it's touching, that'll work. And then we want to touch this bottom to this wire, and then we also want to connect this wire to the positive terminal of the battery. And voila, we have light. And that would be a series circuit. It slipped off, but I think you get the idea. Yeah, so that when you're talking about a series circuit, instead of the resistance going down, it actually goes up the more resistors are added. So there we go. Let's light it again. Woohoo! If you can see that, the resistance actually goes up the more the resistors that are added. So that's why they get dimmer the more that are added. Cool. And yeah, to finish up that crystal story, crystals aren't actually conductive by default. The people in that article, people that were involved with that were Matt McCluskey, Poole, and Slade Jokela. This article was written by Eric Sorensen, and according to him, crystals aren't conductive by default. The experimenters used strontium titanate and heated it in a certain way, and after that, the light was able to give it conductive properties. And another cool thing is that crystal could be put back to its original form, and they could actually create another circuit out of it. They could do that by heating it on a hot plate and reshaping it. And just to give credit to the other article, people involved with that. Never mind, I read that already. Just remembered it. Thank you.